The Milky Way isn't just a band of light in the night sky. It's a cosmic detective story waiting to be unraveled. Right now, hidden in its spiraling arms and ancient stardust, there are secrets so strange they sound like science fiction. What if I told you our galaxy holds a supermassive black hole with the appetite of 1,000,000 suns? Or that somewhere out there, entire planets might be made of solid diamond? Buckle up, because we're diving into 25 jaw-dropping galactic mysteries, facts so wild, they'll make you question everything you thought you knew about our celestial home. This isn't just astronomy, it's an interstellar treasure hunt, and you've got a front row seat. Deep within the Milky Way's vast shadow, astronomers found something they never expected, a hidden twin lurking right next door. Meet Antlia 2, a ghostly galaxy so faint it's practically invisible, drifting through our cosmic neighborhood like a phantom. This isn't some distant speck of light, it's orbiting us, hidden in plain sight for billions of years. How does an entire galaxy just disappear? The secret lies in its strange, wispy structure. Antlia 2 is bloated, stretched thin, and packed with dark matter, making it 1,000 times dimmer than it should be. Picture trying to spot a cloud of smoke against a moonless sky. That's how elusive this cosmic shadow is. And here's the twist. Its dark matter might hold clues to why our own galaxy hasn't torn itself apart. Some scientists think Antlia 2 could be a fossil from the Milky Way's violent past, a relic of collisions that shaped us. So next time you gaze up at the stars, remember, there's a ghost out there dancing silently in the dark. But the Milky Way isn't just hiding a ghostly twin. It's got a dark appetite buried in its past. Our galaxy is a cosmic predator, shredding and swallowing smaller neighbors in a slow-motion feeding frenzy. Take Gaia Enceladus, a dwarf galaxy that once danced too close. 10 billion years ago, our hungry spiral ripped it apart, leaving behind glittering scars in the sky, stellar streams like cosmic breadcrumbs tracing a forgotten feast. Today, telescopes spot these rivers of stars, remnants of that ancient collision still orbiting in silent testimony, and Gaia Enceladus wasn't alone. The Milky Way's halo brims with these stellar fossils, evidence of at least a dozen galactic meals. Picture it, every time our galaxy grew, it wasn't just from gas and dust, it was from cannibalizing its neighbors. Even now, we're digesting the Sagittarius dwarf, a galaxy caught in a death spiral, stretching into starry tendrils. This isn't just history, it's still happening. So while the night sky seems serene, remember, the Milky Way is a silent hunter, and its next cosmic meal might already be in sight. Rising from the Milky Way's core like two colossal balloons stretching halfway across the visible sky are the Fermi Bubbles, an enigma wrapped in gamma rays. Discovered just over a decade ago, these towering structures blast high-energy radiation into space, each one soaring 25,000 light-years above and below our galactic plane. Imagine twin geysers of cosmic energy, so vast they could engulf entire constellations. Their origin, a feverish debate among astronomers. The leading theory points to Sagittarius, a star, our galaxy's supermassive black hole, which may have unleashed a cataclysmic belch of energy millions of years ago. An eruption so powerful it punched through the Milky Way's gas and dust, leaving these shimmering remnants. But here's what keeps scientists up at night. The bubbles glow in gamma rays, the universe's most energetic light, yet there's no clear explanation for how they're still radiating so intensely after eons. Some speculate it's the aftermath of a black hole feast, a star torn apart, its matter converted into a monstrous particle jet. Others whisper about dark matter collisions deep in the galactic heart. Whatever the cause, one thing's certain, these aren't just static leftovers. The Fermi Bubbles thrum with secrets, a cosmic alarm ringing from the past, reminding us that even our own galaxy has chapters we've barely begun to read. Out there, spinning around a dead star, is a world that would make a jeweler's heart race. Scientists call it pulsar J17191438b, but you can think of it as the galaxy's ultimate treasure chest, a planet likely made almost entirely of solid diamond. This isn't science fiction, it's the bizarre aftermath of cosmic cannibalism. The story begins with a pulsar, the dense, spinning corpse of a once mighty star. Its gravity is so ruthless that it shredded a neighboring star, stripping away layers until only the core remained, a core so rich in carbon that under insane pressure, it crystallized into a planet-sized gem. Picture this, a world where mountains might glitter like cut stones, and the very ground beneath your feet could be a single, monstrous diamond. But here's the catch, this isn't some serene jewel floating in space. It orbits its pulsar in just 2 hours, lashed by radiation and trapped in a gravitational vise. The universe, it seems, has a dark sense of humor, crafting something so dazzling in a place no one could ever reach. And the wildest part, this diamond planet might not be alone. Some astronomers suspect the cosmos could be littered with these crystalline oddities, remnants of stars that dared to dance too close to their destructive partners. So next time you admire a diamond ring, remember the universe has been crafting its own bling for billions of years on a scale we can barely fathom. Somewhere out in the cosmic deep, an invisible force is dragging us through space at breakneck speed, and we still can't see what's doing the pulling. Meet the Great Attractor, a gravitational mystery so powerful it yanks entire galaxies, including our own Milky Way, toward it at 1.4 million miles per hour. That's like racing from Earth to the moon in just 15 minutes. But here's the cosmic irony. The very thing we're hurtling toward is hidden behind a curtain of stars, gas, and dust, the so-called zone of avoidance. This dense region near the Milky Way's core blocks our view like a celestial blindfold, leaving astronomers to piece together clues from whatever faint signals leak through. What we do know is terrifyingly fascinating. The Great Attractor isn't just pulling us, it's pulling thousands of galaxies in our local supercluster, as if space itself were a conveyor belt tilted in its direction. Some researchers think it might be a colossal cluster of galaxies, weighing as much as tens of thousands of Milky Ways. Others speculate it's something even stranger, a gravitational echo from structures beyond our observable universe, a shadow of something greater we can't yet comprehend. And the plot thickens. Recent discoveries hint that the Great Attractor might just be a pit stop on an even larger journey. Behind it lies the Shapley supercluster, an unfathomable gathering of galaxies that could be the true heavyweight champion of our cosmic neighborhood. So while we're caught in this relentless pull, remember, it's not just about where we're going, but what invisible giants might be lurking along the way. The universe, it seems, loves a good game of hide and seek, especially when the stakes are the fate of entire galaxies. The Milky Way isn't just moving, it's caught in a cosmic current so vast it defies everything we thought we knew about the universe. Scientists call it the dark flow, and it's as unsettling as it sounds. Imagine this, thousands of galaxy clusters, including our own, drifting in the same direction like leaves swept by an invisible river. But here's the catch, this river has no source we can see. It's pulling matter toward something outside our observable universe, something so massive it warps the fabric of space itself from beyond the cosmic horizon. The clues first surfaced in 2008, when astronomers noticed galaxy clusters hurtling toward a single point at speeds that shouldn't be possible. Gravity from known structures couldn't explain it, not even the Great Attractor. This motion suggests an unseeable force, perhaps a supercluster of unimaginable scale, or even a remnant of a pre-Big Bang reality tugging at the edges of our cosmos. The unsettling implication, our universe might be just one bubble in an endless froth of others, each with its own gravity, its own rules. What's truly mind-bending is the scale. The dark flow stretches over billions of light years, carving a path through nothingness as if the universe itself is tilting. Some theories whisper about parallel dimensions or cosmic defects in space-time, glitches left over from creation. Others argue it's evidence of an ancient collision with another universe, a scar we're still drifting away from. For now, the dark flow remains one of astronomy's most profound mysteries, a silent reminder that the universe still holds cards it hasn't shown us. So when you look up at the night sky, remember, we're not just orbiting the sun or even the galaxy. We're passengers on something far grander, caught in a current whose origins might forever lie in the dark. Stretching like invisible spiderwebs from the heart of our galaxy, vast magnetic filaments twist through space, some longer than the distance between Earth and its nearest stars. Astronomers recently mapped these eerie structures near Sagittarius, a star, revealing tendrils of energy up to 150 light-years long, crackling with cosmic power. But here's the mystery: no one knows exactly how they formed. One theory suggests they're scars from past eruptions of the supermassive black hole, like smoke trails from a celestial explosion. Others believe these filaments might be cosmic particle accelerators, twisting electrons into high-energy spirals that glow in radio waves. What's truly bizarre is their symmetry. These filaments line up with the galaxy's spin axis like compass needles pointing to some unseen force. It's almost as if the Milky Way itself has a hidden magnetic skeleton, quietly shaping the chaos around it, and the plot thickens. Some filaments seem to connect to a colossal structure called the chimney, a tunnel of hot gas blasting outward from the galactic center. Could these be escape routes for energy fleeing the black hole's grasp, or perhaps they're cosmic lightning rods channeling power across the galaxy? What's certain is that their discovery shatters old assumptions. For decades, we pictured magnetic fields as gentle, uniform forces. Now we know they can form ghostly braids strong enough to steer stars. As telescopes probe deeper, one thing becomes clear: the Milky Way isn't just a swirl of stars and dust. It's a living, pulsing web of forces, and these filaments, they might just be the threads holding the entire tapestry together. One of the strangest disappearing acts in cosmic history unfolded around Fomalhaut, a young star just 25 light-years away. Astronomers watched for years as its supposed planet, Fomalhaut b, made its slow orbit until one day it simply faded from view. At first, scientists believed they'd found a Jupiter-like world, starring in the first direct image of an exoplanet taken in visible light. But the deeper they looked, the more puzzling it became. Instead of growing sharper, the planet's signal spread out like a ghost dissolving into mist. The truth, Fomalhaut b might never have been a planet at all. New evidence suggests it could have been the aftermath of a cataclysmic crash, a titanic collision between two icy worlds, leaving behind an expanding debris field that briefly mimicked a planet's glow. Picture two asteroids, each dwarfing the largest mountains on Earth, slamming together with such force they vaporized into a swirling fog of dust. That's the kind of violence that could have fooled our telescopes. Yet this vanishing act raises even wilder possibilities. If collisions like this are common around young stars, we might be witnessing the chaotic birth of an entire planetary system, where worlds form not just from gentle dust clumping, but from brutal, shattering impacts. Some researchers think Fomalhaut's debris cloud could one day coalesce into real planets, making this a fleeting glimpse of creation in action. So while Fomalhaut b may have been a cosmic mirage, its legacy reshapes how we think about the turbulent origins of alien worlds, proving sometimes the universe's greatest tricks aren't in what's there, but in what we think we see. Lurking in the darkness between stars, there's a population of cosmic outlaws, rogue black holes, untethered from any star or system, drifting silently through the Milky Way. Astronomers estimate there could be as many as 100 million of these gravitational renegades wandering our galaxy, each one a relic of violence written in the fabric of space itself. Most black holes form when massive stars collapse, but the rogues, they're the survivors of chaotic cosmic encounters. Picture two black holes locked in a gravitational tango, spiraling closer until they collide with such force that the recoil launches the newborn singularity into the void. Others might have been flung from their birthplaces by close encounters with other massive objects, doomed to roam the galaxy alone. Here's what keeps scientists on edge. These invisible drifters could pass right through a solar system without warning. Their gravity is so intense that even from a distance of a few billion miles, they could yank planets from their orbits or send comets hurtling inward. The good news, the odds of one getting too close are astronomically low, but not zero. Yet rogue black holes aren't just agents of chaos. Some researchers believe they could be the missing link in explaining strange stellar motions or even the seeds of future galactic mergers. Imagine a lone black hole drifting for eons, only to be captured by another galaxy's gravity, a silent hitchhiker in the cosmic dark. So while we scan the skies for distant supermassive black holes, remember, the real shadowy figures might already be here, moving unseen through the night. The Milky Way isn't just home to stars and planets, it's a hunting ground for the universe's most elusive ghosts. From the depths of interstellar space comes a signal so powerful, it outshines entire galaxies, if only for a millisecond. Fast radio bursts, or FRB, are cosmic flashes of radio energy so intense that each pulse carries as much power as 500 suns. And the strangest part, some repeat like clockwork, flashing again and again from the same spot in the void. At first, astronomers thought these bursts might be the death cries of neutron stars or the echoes of black hole collisions. But then they caught something inexplicable, one particular FRB, known as 1212, sending out bursts in a predictable 157-day cycle. Active for 90 days, silent for 67, then repeating like an interstellar metronome. Natural cosmic events don't keep schedules this precise. Which raises the tantalizing question, could these be more than just stellar misfires? Some scientists speculate they might be evidence of advanced technology, cosmic lighthouses, navigation beacons, or even leakage from alien propulsion systems harnessing unimaginable energy. Picture a civilization tapping into the fabric of space itself, sending pulsed messages across galaxies, their signals so powerful they survive journeys lasting millions of years. Yet the truth might be even stranger. Recent studies trace repeating FRBs to regions with intense magnetic fields, like the neighborhoods of young magnetars, neutron stars with magnetic grips strong enough to shred atoms. But even that doesn't fully explain the patterns. Whether natural or engineered, one thing's certain, every new detection rewrites the rules. These bursts might be the universe's most cryptic postcards, carrying secrets we're only beginning to decode. So the next time you hear about a fast radio burst, remember, it might not just be space talking. It could be the closest thing we've found to a galactic internet, blinking messages we don't yet know how to read. Hidden in plain sight, there's a cosmic accounting error plaguing astronomers, one where nearly half the Milky Way's expected matter simply can't be found. This isn't dark matter or some exotic mystery, it's the missing baryon problem, and it's as baffling as a magician's trick where the rabbit vanishes mid-air. Baryons are the ordinary stuff of the universe: protons, neutrons, the building blocks of stars, planets, even our own bodies. Based on cosmic calculations, we should see far more of them than we actually detect. The numbers don't lie. Around 50% of the Milky Way's predicted baryonic matter is unaccounted for. So where did it all go? The leading theory points to something called the warm-hot intergalactic medium, or WIM, a vast, diffuse network of superheated gas threading between galaxies. Imagine a ghostly ocean of plasma, so thin it's nearly invisible, yet spanning billions of light years. This isn't the crisp emptiness of deep space. It's more like steam rising from a cosmic kettle, hiding in plain sight by being too faint and too spread out for most telescopes to spot. But astronomers aren't giving up the hunt. By studying how distant quasars flicker as their light passes through these elusive filaments, they've begun to piece together clues. The WIM gas is scorching up to 1,000,000 degrees, but so sparse that a cubic meter might hold just a single atom. That's why it's evaded detection for so long. New X-ray telescopes are finally peeling back the curtain, revealing faint glows where matter clumps ever so slightly. Here's the twist: this missing matter might not stay missing forever. Some of it could be cycling back into galaxies, fueling future star formation. The Milky Way could be breathing this gas in and out like a cosmic lung in a process we're only starting to understand. So while the Baryons may be hiding, they're not gone just waiting for us to sharpen our tools and uncover their secret resting places. The universe, it seems, loves a good game of hide and seek even with its own building blocks. Some stars don't just shine, they flee. Imagine being hurled through space at 1.5 million miles per hour, fast enough to cross the entire United States in less than a second. That's the reality for hypervelocity stars, cosmic fugitives rocketing out of the Milky Way with enough speed to escape its gravitational grip forever. And their origin story, a celestial slingshot powered by our galaxy's most ruthless force, the supermassive black hole at its heart. When two stars orbit each other too close to Sagittarius, a star, things get violent. The black hole's gravity rips them apart, capturing one star while flinging the other outward like a stone from a catapult. This isn't just a gentle nudge, it's a gravitational kick so powerful that the surviving star launches into the void at speeds that defy logic. Picture a cosmic pinball machine where the stakes are a one-way ticket out of the galaxy. But here's the twist: these runaway stars aren't just space oddities. They're interstellar breadcrumbs revealing secrets about the black hole's feeding habits. By tracing their paths backward, astronomers can map the hidden dance of stars near the galactic center, a region too crowded and chaotic to observe directly. Some hypervelocity stars even carry traces of their origins in their composition, like chemical fingerprints hinting at the violent moment they were torn free. And the surprises don't stop there. A few of these speed demons might not be solo acts. Recent observations suggest some hypervelocity stars could have planets in tow, worlds ripped from their original systems and sent careening into the abyss. Imagine a frozen, rogue planet, its star long gone, hurtling through intergalactic space with only the glow of distant galaxies to light its way. So while most stars live quiet lives in predictable orbits, these hypervelocity renegades remind us that the Milky Way has a wild side. They're proof that even in the vastness of space, gravity can play the role of both architect and destroyer, sculpting the galaxy, even as it hurls pieces of itself into the unknown. For decades, scientists pictured the Milky Way's dark matter halo as a perfect sphere, a vast, invisible cocoon enveloping our galaxy in all directions. But nature rarely follows neat geometry. New research suggests this mysterious halo might be squashed, lopsided, or even warped like a cosmic pancake, an idea that upends how we measure the galaxy's true weight. The clues come from the outer edges of the Milky Way, where stars don't move as predicted. Instead of orbiting smoothly, they show peculiar velocities, as if tugged by unseen hands from odd angles. Simulations now reveal this could mean dark matter isn't evenly distributed. It might be clumped in dense ribbons or stretched into an oval, its gravity pulling stars off course. Even more intriguing, some studies point to a tilted halo where dark matter's orientation doesn't align with the visible galactic disk. Picture spinning a dinner plate, then nudging it slightly off-center. That's the kind of gravitational imbalance astronomers are detecting. This isn't just a cosmic quirk. If dark matter isn't spherical, our estimates for the Milky Way's mass could be off by staggering amounts, perhaps by as much as 50%. The implications ripple outward. A flattened halo might explain why satellite galaxies orbit in strange planes instead of scattered around us. It could also reshape our understanding of how galaxies collide, merge, and grow over billions of years. The universe, it seems, prefers its mysteries wrapped in irregular packages, forcing us to rethink even the most fundamental assumptions about the invisible scaffolding of reality. So while dark matter remains elusive, its shape-shifting nature reminds us the cosmos loves to defy expectations. What we can't see might not just hide in plain sight, it could be staring back at us from an angle we never thought to look. Beyond Neptune's orbit, something massive is warping the paths of distant icy worlds, and the hunt for this hidden giant has become one of astronomy's greatest detective stories. Meet Planet 9, the hypothetical world that could rewrite our solar system's map. The clues are impossible to ignore. A cluster of small objects in the Kuiper belt, icy remnants from the solar system's birth, move in strangely aligned orbits as if tugged by an unseen hand. Their trajectories tilt at similar angles, grouped in a way that odds say shouldn't happen randomly. The math points to a culprit, a planet roughly 5 to 10 times Earth's mass, lurking 20 times farther from the Sun than Neptune. But finding it, that's the real challenge. This phantom world would reflect so little sunlight that spotting it is like searching for a single dim street lamp across the span of a continent. Telescopes have scanned swaths of sky, sifting through billions of faint dots, yet so far, Planet 9 remains elusive. Some researchers think it might be hiding near the galaxy's dense starfields, camouflaged amid cosmic clutter. Others suggest its orbit could be far more tilted than we've assumed, throwing off search patterns. The intrigue deepens with every passing year. New simulations hint that Planet 9 might not be alone. It could have siblings or even be an exiled rogue planet captured by the Sun's gravity long ago. Then there's the wildest theory of all, that what we're seeing isn't a planet at all, but a primordial black hole, no larger than a grapefruit yet massive enough to bend orbits with its gravitational grip. Whether it's a frozen super-Earth or something far stranger, one thing's certain: the outer solar system holds secrets we've barely begun to uncover. Every undiscovered object out there is a reminder our cosmic neighborhood still has shadows deep enough to hide giants. At the heart of the Milky Way, twin torrents of energy blast outward like cosmic fire hoses, jets of superheated particles stretching 50,000 light-years into the void. These aren't just random eruptions, they're the galaxy's own internal pressure valves, releasing energy so intense it could rewind the evolution of entire star systems. Scientists call them galactic winds, fountains of charged particles spewing from the core at nearly 2 million miles per hour. Picture the force of a million supernova channeled into two narrow streams, punching through the galaxy's gas and dust like a laser through fog. What's fueling them? The prime suspects are our supermassive black hole and the frenzied star factories surrounding it. When hundreds of massive stars ignite in tight clusters, their combined radiation and stellar winds create shockwaves powerful enough to launch matter beyond the galaxy's grasp. But the black hole plays its own role. Every time Sagittarius, a star, devours a nearby gas cloud or star, it doesn't just swallow matter quietly, it fires back. Some of that material gets funneled into jets, catapulted outward by magnetic fields, twisted into cosmic particle accelerators. The result, a feedback loop where the galaxy's heart both consumes and expels, balancing creation and destruction on a scale we're only beginning to measure. Here's the twist: these geysers might be sculpting the Milky Way's future. By ejecting matter at such speeds, they're starving entire regions of the raw materials needed to form new stars, effectively putting a galactic lid on star birth in some neighborhoods while seeding others with enriched elements for future worlds. It's a reminder, even the most violent forces in space can shape the universe in ways as delicate as they are dramatic. Tucked away in the Milky Way's halo, there's a star so ancient it remembers the universe's first dawn. Meet 2 Mass J 18,082,002 5,104,378, a lonely wanderer with a heartbeat older than most galaxies. This faint, unassuming speck of light is one of the rarest treasures in existence, a second-generation star, born just a few 100 million years after the Big Bang. Its secret, a composition so primitive it's almost pure hydrogen and helium, with barely a whisper of heavier elements. To understand why this matters, picture the early cosmos as a vast, empty kitchen. The first stars were the universe's original chefs, massive, short-lived giants that cooked up the first heavy elements in their nuclear furnaces. When they exploded, they scattered these ingredients across space. But 2 mass J 18,082,002, 5,104,378. It formed from the leftovers of those first feasts before the cosmic pantry was fully stocked. Its iron content is 15 million times lower than our sun's, like finding a recipe written before humans discovered salt. This star isn't just old, it's a time capsule. Its light carries fingerprints from an era when galaxies were just beginning to coalesce, and the Milky Way itself was a swirling cloud of potential. By studying it, astronomers have uncovered something startling. The early universe might have formed stars in quiet, low-density pockets, far from the violent stellar nurseries we see today. Yet the real surprise is its location. Most ancient stars hide in distant globular clusters, but this one drifts alone through the galactic outskirts, a relic that somehow survived billions of years without being absorbed or destroyed. Its very existence challenges assumptions about how early structures formed. If stars like this could take root in isolation, the infant universe might have been far more diverse than we ever imagined. So while 2 mass J 18,082,002, 5,104,378 might not shine brightly, its story illuminates our cosmic origins like no other. It's a living fossil, proof that sometimes the quietest voices hold the loudest echoes of history. Beneath icy crusts in the darkest corners of our solar system, entire oceans churn hidden seas that could rewrite the search for life beyond Earth. Take Europa, Jupiter's enigmatic moon. Its frozen surface is scarred with cracks, betraying the vast saltwater ocean beneath. Scientists estimate this submerged world holds twice as much liquid water as all of Earth's oceans combined, kept warm by the moon's constant flexing under Jupiter's gravitational pull. But Europa isn't alone. Saturn's moon Enceladus sprays plumes of water into space through geysers at its south pole, direct evidence of a subsurface ocean tasting of organic compounds. The implications are staggering. If tiny, ice-covered moons like these can host liquid water and the chemical building blocks for life, how many more could be out there? Recent models suggest subsurface oceans might be the rule, not the exception, for moons orbiting gas giants. Even Pluto, once written off as a frozen relic, shows signs of a sloshing underground sea, its heart-shaped basin hinting at geologic activity beneath the ice. Now imagine scaling this up galaxy-wide. Around distant exoplanets, countless icy moons could be hiding similar oceans, shielded from harsh radiation by thick frozen shells. Some might be far older than Earth's oceans, simmering quietly for billions of years, enough time for life to emerge in slow, alien rhythms. Hydrothermal vents, like those fueling Earth's deepest ecosystems, could dot these dark seafloors, offering havens for microbes or even complex organisms evolved without sunlight. The hunt is already underway. Missions like NASA Europa Clipper will soon skim the moon's surface, analyzing ejected material for biosignatures. Meanwhile, telescope surveys scan exoplanet systems for water worlds with telltale glints of ice. This isn't just about finding extraterrestrial life, it's about realizing how inventive the universe can be. Oceans don't need sunny shores to thrive. Sometimes they lurk in the unlikeliest places, whispering secrets through cracks in the ice. Gliding through the Milky Way's spiraling dance, astronomers have stumbled upon a cosmic illusion. Some of its grandest arms seem to vanish like ink dissolving in water. These phantom spirals aren't flaws in our maps, they're clues to a deeper mystery about how galaxies evolve. While textbook images show perfect, sweeping arms, the truth is far messier. Entire segments appear fractured, as if the galaxy itself can't decide where its structure begins or ends. The leading explanation: spiral arms might not be permanent fixtures at all. Imagine traffic on a highway, cars bunched together, creating the illusion of a slow-moving wave, even though individual vehicles keep speeding ahead. Similarly, stars and gas could be clustering temporarily in density waves, surging through space like cosmic sound waves that leave no physical trail. This would mean the Milky Way's arms aren't rigid structures, but shimmering patterns, constantly reforming as they're shepherded by gravity's invisible hand. But there's a twist. Some researchers argue these gaps aren't just fleeting, they could be scars from past galactic close calls. When smaller galaxies collide with the Milky Way, their gravitational pull might shred segments of our spiral arms, leaving behind tattered edges that take eons to heal. Others propose a wilder idea. Dark matter's uneven distribution could warp the galaxy's shape from within, twisting its arms into fragments we struggle to trace. What's certain is this: the Milky Way's imperfections tell a richer story than any flawless portrait ever could. Every gap, every fractured spiral, is a snapshot of forces shaping the galaxy in real time, a reminder that even the grandest cosmic designs are works in progress. So the next time you see an image of our galaxy's arms, look closely. The missing pieces aren't errors, they're unfinished verses in an epic still being written. Imagine a galaxy where the night never ends, not because stars are faint, but because they barely exist at all. Meet Dragonfly 44, a cosmic paradox floating in the constellation Coma Berenices. At first glance, it looks like a ghostly smudge, barely visible even to our most powerful telescopes. But the truth behind its dim glow is far stranger. This galaxy is made almost entirely of dark matter, with stars so sparse you could fly between them for light years without seeing a single spark. Here's what makes Dragonfly 44 defy logic. Despite spanning as wide as the Milky Way, it contains just 1% of our galaxy's stars, yet it doesn't fly apart. Something invisible must be holding it together with a gravitational grip strong enough to replace the missing starlight. That something, a staggering halo of dark matter weighing as much as 2 trillion suns. If our galaxy were an iceberg, its stars would be the visible tip. Dragonfly 44, by contrast, is almost all submerged mass, a shadowy leviathan lurking in the cosmic deep. But how does something like this even form? Current models suggest galaxies grow around dense knots of dark matter, with stars igniting as gas pools at their cores. Yet Dragonfly 44 dark matter outweighs expectations by a factor of hundreds, as if the universe forgot to light the fuse for star formation. One theory points to a tragic past. Perhaps it was once a thriving galaxy, stripped of its gas by cosmic tides or violent encounters, leaving behind a skeletal framework of dark matter and a handful of surviving stars. Others propose it's a primordial relic, a rare survivor from an era when dark matter dominated even more intensely than today. The implications rattle astrophysics at its foundations. If galaxies like Dragonfly 44 are more common than we thought, we might need to rewrite the rules of how structure emerges in the universe. Even stranger. These dark galaxies could be hiding in plain sight all around us, their faint signatures drowned out by brighter neighbors. They challenge us to ask, is the cosmos we see truly the cosmos that's there, or just the sliver of it that shines? So while Dragonfly 44 might seem like a cosmic aberration, it's really a mirror. In its starless depths, we're forced to confront how little we truly understand about the invisible scaffolding of reality, and how much more might be out there waiting in the dark. At the very heart of the Milky Way, where gravity twists the rules of reality, time itself begins to stutter. Sagittarius, a star, our galaxy's supermassive black hole, doesn't just warp space, it stretches moments like taffy, creating a cosmic slow-motion zone where clocks tick at a fraction of their normal speed. If you could hover near its event horizon, just beyond the point of no return, you'd witness something bizarre. The outside universe would appear to speed up, stars blinking like strobe lights, while your own seconds dragged on endlessly. This isn't science fiction, it's Einstein's theory of relativity in action. The black hole's crushing gravity bends time so severely that an hour near Sagittarius, a star, could equal years elsewhere in the galaxy. The effect grows more extreme the closer you get. Imagine watching entire civilizations rise and fall in what feels like an afternoon, or seeing the sun's lifespan flash before your eyes in mere days. For a hypothetical observer, this time dilation would be both awe-inspiring and perilous. One misstep too close, and the tidal forces would stretch you into a stream of atoms, but linger at the right distance, and you'd become a time traveler of sorts, outliving the universe around you. Yet the implications reach far beyond thought experiments. This extreme time warp affects how we observe the black hole itself. Gas clouds spiraling toward Sagittarius, a star, appear to freeze in our telescopes, their light redshifted and stretched into near-infinite wavelength. Even the black hole's shadow, famously captured in the first-ever image, is subtly distorted by these relativistic effects, like a funhouse mirror reflecting the laws of physics back at us. What's truly humbling, this time-bending grip isn't unique. Every massive object warps time, even Earth, just by a fraction of a second over decades. But Sagittarius, a star, shows us the universe's full toolkit, revealing how gravity can sculpt not just space, but the very flow of existence. So while we may never visit its edge, the black hole's silent lesson remains. Time is far more fluid than our clocks suggest, and the cosmos holds pockets where eternity unfolds in the blink of an eye. Scattered across the Milky Way like celestial metronomes, pulsars keep time with staggering precision, some so accurate they rival atomic clocks here on Earth. These rapidly spinning neutron stars emit beams of radiation that sweep across space with each rotation, creating flashes detectable across thousands of light years. What makes them extraordinary isn't just their rhythm, but how they could serve as the universe's ultimate GPS for future interstellar travelers. Take the famous PSRB 1937+21, a pulsar spinning 642 times per second, so fast its surface moves at nearly a quarter the speed of light. Each pulse arrives with nanosecond consistency, allowing astronomers to track its timing like a cosmic heartbeat. This reliability is why NASA included pulsar maps on the Pioneer plaques and Voyager records, an invitation for extraterrestrial navigators to locate Earth using these natural beacons. But the real magic lies in their three-dimensional potential. Imagine a spacecraft triangulating its position by comparing the pulse arrival times from multiple pulsars, each acting as a unique lighthouse in the dark. Unlike human-made satellites, these markers never drift or fail, they're anchored by the laws of physics itself. Some millisecond pulsars, spun up by accreting matter from companion stars, are so stable their timing can detect gravitational waves rippling through space-time. Yet pulsar navigation isn't without challenges. Their signals weaken over distance, and intervening gas clouds can scatter the beams. Future explorers might need sensitive receivers to lock onto these whispers across light years. But the promise remains. In a galaxy without road signs, nature has already provided a solution, a network of spinning sentinels, their rhythmic flashes etching paths through the void. What began as a curiosity, the discovery of little green men signals in 1967, has become one of the universe's most elegant gifts. Whether guiding probes or civilizations, pulsars remind us that the cosmos doesn't just inspire wonder, it offers tools to navigate its vastness, one precise pulse at a time. Among the Milky Way's many mysteries, few are as oddly violent as the invisible bullets ripping through its heart. These aren't actual projectiles, they're colossal clouds of gas, hurtling at speeds up to 700,000 miles per hour, some so massive they dwarf entire star systems. Take the Smith Cloud, a gargantuan stream of hydrogen barreling toward our galactic disk with enough energy to light up millions of stars, the strangest part. It shouldn't exist. Gas clouds this dense usually get torn apart when they collide with the Milky Way's spiral arms, yet the Smith Cloud has survived its deadly plunge not once but twice. Astronomers tracked its path and found something baffling. It's on a boomerang orbit, having already punched through the disk once before and now returning like a cosmic boomerang. What's shielding it? One theory suggests an invisible cloak of dark matter might be cocooning the cloud, acting as a protective shield against the forces that should vaporize it. But the plot thickens. The Smith Cloud isn't alone. Other high-velocity clouds, like the famously misnamed Fermi Bubbles, despite their name, they're not the same as the gamma-ray structures near the core, streak through the galaxy's halo with unexplained momentum. Some might be intergalactic hitchhikers captured by the Milky Way's gravity from the sparse gas-bridging galaxies. Others could be the fallout of ancient supernova, blasted outward only to rain back down in deadly, high-speed torrents. Here's what keeps scientists riveted. These clouds aren't just space oddities, they're delivery trucks for star fuel. When they eventually collide with the galactic disk, their gas could ignite new stellar nurseries, literally shaping the Milky Way's future one collision at a time. So while these invisible bullets remain enigmatic, one thing's clear: the galaxy isn't just a serene swirl of stars, it's a shooting range where the ammunition is as mysterious as the forces firing it. In the bustling stellar neighborhoods of the Milky Way, astronomers keep finding cosmic imposters, stars that refuse to grow old gracefully. Meet the blue stragglers, ancient stars masquerading as youthful hotshots, burning brighter and bluer than their peers. These celestial anomalies flaunt colors typically seen in stars 10 times younger, like pensioners showing up to a high school reunion in tight jeans and dyed hair. So what's their secret? One theory suggests stellar vampirism, a dramatic scenario where one star siphons gas from a nearby companion, rejuvenating itself with stolen fuel. Picture a cosmic parasite growing younger while its victim withers into a faint ember. But there's another, even wilder possibility: collisions. In densely packed globular clusters, stars can smash together like billiard balls, merging into a single, hotter, bluer Frankenstein's monster of a star. The oddest detail: these zombie stars don't just defy expectations, they rewrite the rules of stellar life cycles. Normally, stars fade predictably as they exhaust their fuel, but blue stragglers seem to cheat death by tapping into new energy sources, whether through theft or celestial fender benders. Telescopes have spotted them everywhere, from ancient star clusters to the Milky Way's quieter suburbs, proving that even in the vastness of space, no two stars age the same way. Yet the mystery deepens. Some blue stragglers show chemical fingerprints of deep cosmic mixing, as if their internal furnaces were stirred by a colossal spoon. Others orbit so close to their victims that they are practically touching, locked in a slow-motion dance of mutual destruction. Whatever's fueling their second act, one thing's clear: the universe has a flair for drama, turning even stellar retirement into a spectacle of rebellion. Lurking in the radiostatic of deep space, astronomers keep stumbling upon cosmic fingerprints, massive rings of energy, so vast they could swallow entire galaxies. These odd radio circles, or ORC, appear out of nowhere on telescope images, glowing like ghostly halos with no visible source. Some span nearly 1 million light-years across, dwarfing even the Milky Way, yet vanish when viewed in other wavelengths of light. So what's sculpting these eerie formations? Theories range from the explosive to the downright bizarre. One leading idea points to black hole mergers, cataclysmic collisions so powerful they send shockwaves rippling through intergalactic gas like pebbles dropped in a pond. When two supermassive black holes spiral together, their final death throes might unleash energy equivalent to billions of supernova, creating expanding bubbles that glow faintly in radio waves. But here's the twist. ORCs don't always show up where black hole mergers are expected. Some float in quiet galactic backwaters, far from the crowded cores where such violence usually occurs. This has led to wilder explanations like dark supernova, hypothetical explosions from stars made entirely of dark matter, or even echoes from long-dead quasars, their light finally reaching us after circumnavigating the universe. The most tantalizing clue: a few ORCs seem to encircle galaxies with actively feeding black holes, as if marking the boundaries of some invisible battlefield. It's possible these rings are cosmic shrapnel, the aftermath of ancient black hole eruptions that took eons to expand to their current sizes. Whatever they are, one thing's clear: ORCs are rewriting the rules of how energy travels through the cosmos. For now, these ghostly circles remain a puzzle, their faint whispers challenging astronomers to listen more closely. In a universe full of violent beginnings and explosive ends, perhaps the quietest signals hold the loudest secrets. Somewhere in the vast cosmic future, about 4 billion years from now, a celestial car crash of unimaginable scale will unfold, one that will rewrite the night sky forever. The Milky Way's serene spiral dance is doomed to collide with our colossal neighbor, the Andromeda Galaxy, in a merger so slow motion it makes tectonic plates seem hasty. When these two galactic titans finally embrace, gravity will sculpt them into something entirely new. Milky Way, a monstrous elliptical galaxy where stars once belonging to separate families mingle like cosmic refugees. For Earth's distant descendants, if any still remain, the view will be nothing short of apocalyptic spectacle. As Andromeda looms closer over millions of years, its spiral arms will stretch across the heavens, growing from a faint smudge to a blazing rival of the Milky Way. Stars won't physically collide, space is too vast for that, but their paths will be flung into chaos, swirling like sparks from a firework. Some will be hurled into intergalactic exile. Others will plunge toward the merging supermassive black holes at the galaxy's cores, destined to become fuel for a future quasar. Yet amid the chaos there's eerie beauty. New star nurseries will ignite as colliding gas clouds compress, painting the infant Milky Way with blue-hot young clusters. The familiar Milky Way band will vanish, replaced by a haze of stars orbiting in all directions, no spirals, just a glowing, football-shaped haze, and Earth's night sky. It could shine 10 times brighter, crammed with so many stars that true darkness becomes a relic of the past. The irony: this collision isn't unique, it's routine in the universe's grand timeline. Galaxies grow by devouring each other, and the Milky Way was already built from smaller mergers. What feels like an ending is really a rebirth, one last transformation before the cosmos dims over trillions of years. So while our galaxy's spiral grace is temporary, its legacy, like all great cosmic stories, is written in the stars it scattered along the way. From ghostly galaxies hiding in our cosmic backyard to diamond planets forged in stellar violence, we've journeyed through the Milky Way's wildest secrets, and yet this is just the beginning. Think about it, our galaxy is a living puzzle where black holes bend time, invisible matter sculpts its shape, and stars flee at breakneck speeds. Every discovery peels back another layer, revealing just how much we don't know. So tell me, which secret left you utterly stunned? Was it the rogue black holes drifting unseen through our neighborhood, or the Milky Way's dark past as a galactic cannibal? Drop your favorite in the comments below. I'm dying to hear which cosmic truth blew your mind the most, and if you're hungry for more intergalactic mysteries, you're in luck. We've barely scratched the surface. From vanishing stars to alien megastructures lurking in deep space, the universe is packed with stories even stranger than fiction. Hit that subscribe button and ring the notification bell, because the next cosmic revelation is always just around the corner. Until then, keep looking up. The night sky isn't just beautiful, it's hiding secrets waiting for you to uncover them.